So my name is Jacob Burley, and today I'm going to be talking about how we use policy to drive automated patch management on Molly. So a little bit about me. My first memory of ever using a Mac was back when they were still called Macintoshes. I was using KidPix on macOS 9, and that was even before I moved to the Netherlands, where I've been living since I was 4. So I've really been using a Mac basically my whole life. Being a Mac admin is kind of a career that makes sense. And I've been doing Mac admin work since the start of 2020. I did an 18-month stint working at the service desk of the university I studied at, and then I moved on up at the start of January 2020 and started doing Mac admin work. And I worked there for 2.5 years. And the summer of 2022, I started working where I work now at Molly. So a little bit more about Molly. Molly is a European payment service provider founded in 2004 by this guy, Adriaan Mol. He is also Molly's first Mac user. And from this image, I think you can get a bit of an idea as to why we use Macs across Molly and why everyone gets a Mac. And fast forward 21 years, we now have over 250,000 merchants, and we help them receive payments from customers using over 30 different payment methods. And we're not just limited to online, we also have now a new, very recently released terminal product. So we can also process in-person payments in brick-and-mortar stores for our merchants. Powering all of this are just shy of 900 people. Most of these people have a Mac. There are some Linux holdouts, but most of them have a Mac. Molly is a financial institution. To accept these payments, we have to have a banking license. And as a financial institution, we have to fulfill certain regulatory requirements. So we're supervised by the Dutch Central Bank, that's DNB on the left. They give us our banking license. And we also handle credit card transactions, so we need to be PCI compliant. And as a European company, we also need to comply with the EU Digital Operational Resiliency Act, otherwise known as DORA. This is not everything that we do from a regulatory standpoint, but these are the biggest ones. These are the ones that we really need to make Molly tick. And to meet all of these requirements, we really need to know how our processes work so that we can demonstrate them to auditors and actually show, okay, this is how we keep our customer and merchant data safe. So what does working by policy actually mean? It means that you're documenting all of your business processes. So we document basically every single repetitive process that we do. So this ranges from vendor onboarding, where we're doing, checking that they're reputable vendors, to something as simple as password policy, but also something a little bit more intense, like, how do we report and detect financial crime? Some of these are very specific to what Molly does in the financial sector, but a lot of them aren't. Like, you probably also have password policy where you work. That's not that unusual. It can feel a little bit like a lot of work to document all of this stuff, to actually maintain all of this policy documentation and actually follow all of these rules. But it has two really, really good benefits for us. First off is for onboarding new hires, because it can seem a bit daunting, but it does mean that actually you can give new hires lots of documentation as to how we do things. It's easy to onboard them in this way. And obviously, it's then great for audits, because we can demonstrate that we have policy for this stuff, and then we can show them exactly how we stick to this policy and show how we monitor our adherence to our own policy. So, policy as code. Once you have your policy written and you have some kind of policy that you're following, what you can do is you can use policy as code, which is writing some kind of code that either implements or defines your policy. There are 3 main advantages for doing this. So automation removes room for human error. If you have a script that's running the same code every single time, it's going to do the same thing every single time. And you can imagine that actually if a human being is executing on policy, and you're actually looking at policy and you're considering all the variables that come into the policy, you might, there's a little bit of room for error, there's room for interpretation, obviously, for what the policy actually means, what it says. And this can be a little bit stressful, can be a little bit overwhelming sometimes with bigger processes. And it can be time consuming. You might have to go back and do research into what specific areas of the policy mean. You might have to reach out to colleagues. What do you think this means? You can save time and ambiguity by writing it as code instead. This does force you to write very descriptive policy, because obviously, that ambiguity you need to eliminate when you're writing your policy as code, but you only have to do it the one time. Computers don't add their own interpretation, traditionally. I think AI is another story, but we're not talking about that here. And if a computer can understand your policy, then like with enough time and enough effort, you should be able to step through your policy as code as well, and also kind of understand why your automation reached the conclusion that it did. And lastly, at Molly. So at Molly, we require peer review if you want to change policy documentation. And that holds also for policy as code changes. You need to make merge requests, they need to be approved by your colleagues, and then they get merged and they become sort of the de facto state of things. So we're going to focus on two business critical processes that we implement as policy as code. The first one of these is application deployment. The second one of these is operating system updates. So we're going to start with app deployment. A little bit of an overview of how we do app deployments and facts and figures. We have 68 self-service titles for users to install self-service whenever they want. And we also have, and these include those 68, 132 total patch titles. So you've got to think there are lots of apps that employees might install because they have admin permissions. But we want to make sure that they keep patched, and we want to make sure that they're keeping up to date with that stuff. We don't want to implicitly approve using some specific apps by adding them in self-service, which is why they're sort of not visible in self-service, but they're still getting patched if you have them installed. Because every single app that we approve for self-service does carry a service desk support burden with it. So, you know, if an employee tries to install something and it doesn't work right, or they're wondering about it, they might then implicitly assume that, you know, this application is supported by IT and I can send all my questions their way, which isn't always the case. I don't want to burden my service desk by adding, you know, 300 apps to self-service. And every week we ingest more than 20 different patch versions across these patch titles. And you can already imagine that actually if I was doing this by hand, if I was packaging 20 apps a week, it would be pretty arduous. I would be pretty busy. So all of our application and delivery patching comes through Monkey. I'm going to preface this that we call Monkey Molly Software Center internally. I might mix them up. They're both the same thing. But Monkey is a really powerful open source internal app store. It's really the best in class of what it does, in my opinion. I've been using it now for almost 5 years across different employers, and I've really not come across anything as useful, as flexible as this. MDM has its own self-service app. We don't use it. We prefer Monkey because of that flexibility. We can control which apps are in there, when they're updated, post and pre-install scripts for everything. You know, it allows us to update apps we don't offer very easily. And also, because all of the configuration for Monkey is in code, and we keep it all in Git, it's essential, actually, for implementing our policy as code automations. As you can see, we rebrand Monkey with Molly branding. Makes it very familiar with employees. We have Molly headers, we have links to the IT help desk within. There are like links in there you can click, and it like opens a Gmail email already for you straight to us. And we have the icon in the dock of every Mac. So that it's like, when you set up a new machine at Molly, you have this one place that all of your software can come from. You associate it with the company, and you know that that's somewhere that you can actually trust software to come from. And we've actually seen this now, especially with like newer waves of new hires, that actually if they can't find software in Molly Software Center, they actually send us tickets and they're like, well, how do I install it? I don't know how to install any software that doesn't come out of Monkey, which is kind of an interesting side effect. I've not had that before, but it's a good sign that people are really using Molly Software Center. We do use Jamf for a little bit of Monkey's functionality. Jamf actually deploys the configuration for Monkey through a configuration profile. But we also use Jamf, and we use a Jamf extension attribute to keep Monkey in a functioning state. So we have one extension attribute that assesses all of the launch daemons, all the launch agents, all the binaries, for now the Python installation, and it just makes sure that it's all working. It makes sure that all of those launch daemons are loaded, that they're not disabled. And for anything that it finds that's wrong, it has like a score, and it increments the score by 1. A non-zero score will trigger a complete reinstall of Monkey from Jamf. And in this way, we can actually catch states where Monkey might seem functional, but maybe it's not running background checks for updates. Maybe when you're opening it, it's like, it's running and it's running interactively, but it's not actually running continually in the background, which would be a bad thing, Monkey is critical for actually how we patch all of our applications, so it really needs to be in a functioning state at all times. So at a high level, this is how our application update deployment workflow is structured. The whole workflow kicks off when a vendor releases a new app version. Then the morning after the new version gets released, AutoPackage will go ahead and ingest it from the vendor's website. So AutoPackage is an open source tool used to automate downloading applications from vendors, if you're not already familiar with it. We consider AutoPackage recipes to be policy documents. They define where apps are sourced from. They define how they're imported into Monkey. They define all the details of, pre and post install scripts, all of that stuff about how, how an application should actually end up on a machine. That's all policy. Once an app has been imported, then we have a sort of a short delay, and it's up to Monkey Promoter to actually start releasing the app to client machines. So this new version gets to be sort of staggered rollout by Monkey Promoter. Monkey Promoter is another open source tool that we use for this purpose. It's purpose written for this. It has rules, and these rules determine when specific apps and when specific versions of these apps actually get out to client machines. And these rules are based on our application update policy internally. So we have a specific SLA for specific different applications, and that's reflected in the policy here. Lastly, once Monkey Promoter has actually released the update to a group of clients, Monkey will actually handle installing the update. So now we have to deal with the scope of the Monkey item. So who it's getting deployed to, who can install it from self-service, who are the patches actually scoped to. This is all determined by Monkey manifests. So manifests in Monkey kind of just control this scope aspect, to keep it simple for now. And because manifests control this deployment, they are also policy as code. They're XML, they're kept in Git, so they require approval to change. So this is the whole thing. You can kind of see how policy is there in every step in this workflow. All of the software we deploy follows this workflow. That also includes internally developed apps, and that also includes Monkey itself. So we build Monkey internally, we rebrand Monkey internally, and AutoPackage grabs it and puts it into this pipeline, and it gets rolled out. This whole process is completely automated. This all happens without any human interaction, but you can intervene manually if you want. So you can go in and you can bump things to production if you want to, if there's like vulnerabilities and stuff that need to be patched. So I did that on Wednesday, I think, for Chrome. And you can also defer updates that are broken. If updates you go to your testing group and you find that actually they don't launch or whatever, then you can just say, okay, let's mark these as on hold, and these won't get promoted out. So let's take a little closer look at each of these steps. So the first of these steps is AutoPackage, where we're ingesting the patch. AutoPackage is, like I said before, an incredibly powerful packaging automation framework. And what it does is it can download and import software for you into your Monkey repository or into your Jamf server, or basically anything you want. It's open source. It's probably at least a couple of you in this room who use AutoPackage already. And it has a large and active development community, both for AutoPackage itself and for community recipes, as we'll talk about in a minute. So how does it actually work? AutoPackage runs what are called recipes. These handle the tasks of actually packaging your apps, simply. They're modular. So in the top right there, we've got like 3 different kinds of recipe. It's possible to write an AutoPackage recipe that does everything from downloading the software, packaging it up, putting it in Monkey. You can have one file that does all of that. But it's better to break it down a little bit like we're seeing here. This is a very common example of how recipes are logically decomposed. So you have a download recipe for actually downloading the software, you have a package recipe for actually packaging it up into a macOS installer package, and then you have a Monkey recipe for actually importing it into your Monkey repository. If you're not using Monkey, and this is where the modularity comes in, if you're using something like Jamf, or if you're using, off the top of my head, something like FileWave even, I've seen FileWave recipes before, then you can swap out the Monkey recipe for a Jamf recipe, and you can keep the other 2 in your chain. So you can actually just reuse your work. I have a couple of recipes where I put Monkey, for example, both into Monkey and into Jamf, and I reuse the download and package recipes, and then the Monkey and Jamf recipes are at the end. These recipes are all joined together by a parent relationship. So with this parent relationship, the recipes can have a parent, and their parent will be run before them. So these arrows indicate the parent relationship. The Monkey recipe has as its parent the package recipe, and the package recipe has as its parent the download recipe. So as an example of how this works, if I were to run this Monkey recipe, it would run the package recipe. It would go, okay, I need to look at the package recipe first. Then it would then the package recipe say, oh, I need to run the download recipe first. And then they would be run in download, package, Monkey order. The reasoning for this is maybe a little intuitive. You can't import something into your Monkey repository that you haven't downloaded yet. Each recipe in this list uses like stepwise operations to complete its task. And these, in order package parlance, these are called processes. Processes are written in Python. Order package comes with a pretty decent variety of them, sorry. But third-party processes are also available. You can write your own. We've written a couple internally for little weird bits and pieces we have. And we're going to look just briefly at some processes that you might find in a download recipe. So the URL downloader processor is pretty common in download recipes because what does it do? Downloads things from a URL. And that's how you get your software down from the vendor website. You also constantly see code signature verifier in download recipes because once you've downloaded your file, what you want to make sure to do sometimes is make sure that it's signed by the authority that you expect it to be signed by. So this is a decent way of trying to prevent supply chain attacks. It doesn't go all the way, obviously. If someone steals your signing keys, this doesn't protect you against that, but it can help you in that regard. This is particularly important if you're auto-promoting your software out to clients, because you do want to be trying to verify the integrity of what you're getting in. So we talked a little bit about community recipes. So Order Package has an active community for Order Package and for the recipes. What this means is, because there's so many community recipes, is that if you're getting started with Order Package and you have a whole list of apps that you need to write recipes for, maybe you don't, you can reuse the recipes that other people have already written. There are a lot of recipes out there, and the chances are someone has already written a recipe for the software that you're trying to use. Order Package also has a nice security feature for this, because you might not be so predisposed to running third-party code from others. So Order Package has this concept called overrides, and these kind of go, I think in this example, kind of at the end of your recipe chain. And what these do is they help you establish trust with the recipes that you're using. So our override here on the right stores trust information for the other 3 recipes in this chain. So we're going to have a little look at what is in an override, just to understand how this works. So this is my override excerpt. It has a parent recipe, so it knows which recipe in the chain that it needs to be pointing to. And you can see that it has entries for all 3 of the recipes in that chain. And it has some very specific information about them. So it has the git hash, so the last git commit that this file was modified in, and it has a SHA-SUM hash for the actual file itself. So if the SHA-SUM hash changes, then the recipe trust will break. And you can see here that I also have Anthony Reimer's text searcher processor up here. So Order Package will also store trust information for third-party processors. This is also particularly useful given that third-party processors are actually Python code, and you can do all kinds of, way more stuff with Python code if you wanted to use it maliciously than you can with, a recipe. And if he makes changes to his processor, then obviously also this trust will be broken. So what does it look like when the trust breaks? You get this nice error. It tells you the contents of your recipe actually aren't what we expected them to be, and the recipe fails. It won't do anything else. This is the default behavior in Order Package. It will not try and download anything. It will just stop. And it will keep doing this, especially if you're running Order Package automatically in an automated fashion. It will keep doing this until you restore the trust. And this also, as you can imagine, then helps a little bit more against supply chain attacks from sort of, malicious takeovers of GitHub accounts that provide Order Package recipes or Order Package processes. Order Package has some tooling to kind of have a look and see what's going on under the hood when this happens. So you have the verify trust info verb. And in this output, Order Package is showing me a git diff because we have those git commits in the override. So it can do a diff between what's actually the current state of this recipe and what we trusted before. And it will show you then literally what's changed since the last time I trusted this. So you can see here that Alan Hutchins, he works at Fleet. I probably merged then a merge request of his, and he's added these 2 lines to my recipe. And that broke the trust. And Order Package has a verb, update trust info, that will just restore this trust for you when you've reviewed what's going on here. So now that we've looked at Order Package, and we've looked a little bit at how it works, how we use it, we can look at the next step in the process, which is automating our release cadence for these apps. So we don't like to release stuff straight from the vendor to our fleet of clients. We want to avoid day 1 bugs. They sometimes happen that they break our colleagues' workflows. They can't get anything done for the day. Sucks all around. But we still want to be able to automate the rollout. We still want to make sure that we're not manually having to do all these deployments. So First thing we need to look at to understand a little bit how this works is how Monkey knows which versions of which apps go on which computers. So Monkey has a mechanism called catalogs that let you control the version of an application that's on a target machine. This was intended for this purpose. It's intended for you to do staggered rollouts of application versions. So in this example we have on the left, we have our order package catalog. So this is where all of our freshly imported software goes first. And you can see that there's no computers underneath it, no computers are getting their software updates and everything from the order package catalog. Next up, you have the staging catalog. This is your testing group. You have a small number of Macs assigned here. My Mac, for example, is in our staging group. We have a couple of volunteers, IT is in there, security domain is in there. We all get new versions a little bit earlier than the rest of the company. In most cases, it's about a week. Sometimes it's a little bit shorter. But we can make sure that actually most stuff is functional just by living on it for a little while. And that's we also try and get volunteers then for application owners of very specific applications that IT might not be using every day. Then lastly, you have your production catalog. They're on the right. This is what your typical employee sees. This is where they get their software. You can have more or fewer catalogs than this. We have these three. We find that this works for us. Our scale is only about 900 machines. But I know of people who use way more, and I know of people who use a few less. I haven't met anyone who uses just the one, but I'm sure it'll happen. And how this basically works is each Monkey item has a field in it that lists the catalogs that it's in. So when we're looking to actually update how applications are moving through this, then what we should be looking at also is, well, how do we update this field? And that's where Monkey Promoter comes in. So Monkey Promoter can update this field for you. It's an open source tool, co-written by me, and it handles promoting your Monkey items between catalogs. And just seeing as I wrote it, I just want to give a little bit more of a background about how it kind of came to be so that you can understand a little bit how it's evolved over the last couple of years. So at a previous employer, I ported a Python 2 Monkey promotion script written by Arjen van Boghoven to Python 3. And we had the script kicking around because we used to do manual promotions. And it was a little bit faster to use this script than it was to do it in something like Monkey Admin. It saved us some time, it was very useful, had a lot of utility, but it didn't do any eligibility criteria checking beyond, oh, is this item already in a catalog? Then I'm going to move it to the next catalog. So if you ran it 2 or 3 times in a row, it would promote an item all the way to production automatically. Saved us time, worth the rewrite to Python 3, but needed some work. In 2023, when I first started messing around with Monkey at Molly, I updated it to respect the import timestamps that are in Monkey items themselves. So when you import stuff into Monkey, be that through order package or through Monkey's own tooling, then it adds a metadata key into your Monkey item metadata. And this says when it was imported. It gives you a timestamp. So what I could do was say, oh, well, let's say I just want to promote things 7 days after they've been in the Monkey repo. And I could look at the timestamp, see how long it had been there, and then promote it if it had been there long enough. And I could run this automatically. I ran it every day. I decided to open source this. That's the first blog post there on the top. And it was perfect for my use. I was really happy with it. It worked. I think we used it for 12 months, maybe 18 months. But there were some drawbacks. People started using it. I spoke to people. I had conversations with people like Betsy Kaiser, other people who had started using it and they wanted to know how to use it. And they'd come across the fact that actually the catalogs themselves and the lengths of time the items were in these catalogs were all hard-coded in the script. So if you didn't know, not any Python, if you didn't know too much Python, it was a bit of a lift to actually start using this and start trying to figure out, okay, how do I make this work? And had I released any updates to it, they would have just reset all of their updates. Not very useful. In 2024, my co-author Kai rewrote the whole thing. It's called version 2. And we started using a configuration file. You can just pick up the script. You don't have to know Python. You can just use it, and you just edit a YAML configuration file with your promotions, and away you go. So we have an example Monkey Promoter configuration here on the right. And you can see that a specific promotion is defined here. And what this does is it promotes items from order package to staging. This applies to all items in the Monkey repository. This example, it covers everything because I haven't put any exclusions or anything like that, so it will do everything. But you can, if you want, you can add exceptions. So sorry, the default here will be that it promotes it from auto package to staging after 7 days. But you can add an exception. So if I wanted to have Google Chrome go out a little bit quicker, so Google Chrome, I think they do like 2 or 3 releases a week. So if you keep it up for 2 weeks, you're already like 8 releases behind. So we do 3 days for Google Chrome before it goes out rather than 7. And this kind of flexibility, this ability to specify like specific inclusions or exclusions and specific rules is kind of the main benefit of Monkey Promoter version 2. So you can really easily define and pick which items are selected from which catalogs, where they end up, you know, give whatever deadlines you like, you can name your promotions, all that fun stuff. You can imagine that if you have an application software update policy, that you can probably describe it in Monkey Promoter configuration. It's pretty flexible. And a side effect of this is that if you have security colleagues and they come to you and they say, well, why did this go out on this day? Or when is this update going to go out? Well, you have an answer. And that's how we use policy to roll out apps. So this leads us to the last step in the process, which is Monkey actually going through and installing the app. So how does Monkey know? We're going to talk about manifests a little bit. Manifests control the specific application that ends up on the machine. So not the version, but the application itself. Not everyone in your organization might have access to the same set of self-service apps. IT has internal IT tooling, for example. So how do you govern this? The answer in Monkey is to use manifests. As a side note, this holds for any Monkey item. This doesn't just hold for apps. I've been saying apps a lot, but any Monkey item is in a manifest, and you can do this with, you know, maintenance scripts, all that good stuff. Monkey lets you use these manifest items, manifest files, to specify the specific items deployed to a machine. And on top of determining the scope, you can also determine the deployment type. So you can say, well, I want this item to be force installed and kept on the machine at all times. Or you can say, well, I want this item to be a self-service install that users can just install whenever they want. There are more types of assignment. Those are kind of the 2 big ones, in my opinion. Yeah. When a computer is assessing what software it gets, it can only look at one manifest. You tell a computer specifically in the client configuration, look at this manifest, and this manifest will help you figure out what software you're getting. But you can include manifests within manifests. So here I've got this nice structure. I've got my root manifest there at the bottom. I've got my site default manifest. And I've got 2 folders. I've got apps and compliance. And these are actual folders in the Monkey repository. And in my apps folder, I have my common apps, and I have my finance apps. And in my compliance folder, I have my compliance items for macOS Sequoia. As a side note, I released Monkey MSCP generator a week ago, which will generate Monkey items for you from MSCP baselines. So if you're using that, then you can put those kind of items in a manifest just like this one. And it's worth noting that these manifests can be conditional. So I've got the finance apps in my apps folder, right? But what if I'm on a not finance computer? Well, you can actually set conditions for including manifests in Monkey. And that because, like we said earlier, every manifest is an XML file, they are policy, they control scoping, and they're also kept in version control, so they are policy as code. We'll just have a little look at our site default manifest from this example. So you can see here at the bottom, we have our included manifests. These are included all the time, unconditionally. So the common apps, Slack, Chrome, people will always get those in Monkey. Then you have conditional manifests. So our finance manifests, our finance apps, they won't be included on a machine unless the machine says, hey, the employee that's using this machine, their Okta department is the finance department. And then also, lastly, we can also just say, okay, the Sequoia compliance apps that are only available on machines with a major version of macOS that is 15. So you're only applying your Sequoia compliance to Sequoia machines. We'll just have a little look at what the common apps manifest looks like. So we have our managed installs, we have Google Chrome, this is force installed all the time. And we have our optional installs. This is Slack, installed on demand by your employees. So how do we put this all together? How does this all come together into this great big automation that we run? All of these steps, when we do this, when we're doing the promotions, the imports, the deployments, they all create commits in Git. So every one of these changes is version controlled. So we can roll stuff back. We can see what changed, when it changed, who changed it. And to power this, we use 3 Git repositories, and they each have their own GitLab runners for this. Autopackage and Monkey Promoter will run once a day each. They run in the early morning, I think Autopackage at 4 and Monkey at 7 a.m. Both of these automations pull the Monkey repository, they make their changes to the Monkey repository, and then they commit it back. And when they commit it back, the Monkey repository runner actually deploys the changes to Google Cloud. So this is where the content is actually served to clients from. Some changes to the Monkey repository might still happen manually, so we still edit manifests manually. We don't have a lot of automation around Monkey manifests. These changes also automatically get deployed when they are merged in, but it's worth noting that employees in IT who are making changes to the Monkey repository, they need to get merge request approval to do any of these changes. You need to make a branch, open a merge request, get an approval. The automated changes don't have this. They don't have to submit their code for review. But all of the automation, if you want to change what the automation is doing, that also obviously requires a code review. So somewhere in this process, you've achieved a review if you've changed something in the automation. So this might seem like a lot of work, a lot of complexity. Why do we do this? It gives us control over literally every aspect of how applications end up on our computers. So we can deploy anything we want, not restricted to our MDM's app catalog. We can deploy internal apps and binaries, internal command line tools, internal little support things in Monkey that do pop-ups for users and show them where to get their logs. We really own our patch cadence. We can roll out apps at the pace of the organization. We can have approval processes and testing rings. If we ever need that stuff in the future, we can just rework it and add it to our approach. And this control doesn't come at the cost of extensibility either. So most of the work we did here was in the initial sort of architecture and setup. And it's been worked on like piecemeal over the last 2.5 years that we've been doing this. But adding an additional patch is almost no work at all. You can add patch titles almost as easily as you can in MDM, at least. And once you've done that, once you've added your patch title and it's being ingested, then you automatically benefit from the fact that it gets rolled out automatically. There's no extra steps required for that. I think you can add an additional patch title to this process in less than 10 minutes, and we taught our service desk employees to do it. So that was our application deployment workflow. Next on, we're going to be moving on to talking about how we handle OS updates, which is kind of similar. So this is our second example of sort of implementing policy as code. So we really heavily try and automate operating system update deployment. There's a reason that we can do this. We target patches for zero-day release. We're on the betas all the time. We're trying to make sure that we can have the latest and greatest macOS as soon as possible. We really want everyone to be up to date. It's kind of common knowledge that Apple tells us that the latest version of macOS is the most secure version of macOS, and that's of strong interest to us as a financial company. And this is a little easier for us because we don't have any legacy hardware. So all of our hardware that we have deployed supports Sequoia at this moment. And looking to the future, less than 5% of our fleet is Intel. We only have about 40 Intel machines left. And they will probably be gone by the time the macOS 26 drops. So that makes approaching this a little bit easier. We don't have to worry about keeping compatibility with old machines. So at a high level, this is what the update automation looks like. Kind of similar to how the Monkey one looked. Apple releases a new version of macOS, and then the SOFA feed gets updated shortly afterwards. So SOFA is an open source feed that contains information about macOS releases. It includes security information, most importantly, which is what we use in the next step, where Nudge Auto Updater, another open source script, takes this information and in combination with our software update policy, our security policy, will propose an enforcement deadline. And it does this through a merge request in Git, which an IT employee has to approve. This is a little different from our app deployment workflow, which doesn't have any approvals from IT employees for promotions. The reason for this is because macOS updates are a little bit more impactful. Hypothetically, a macOS update could render your machine unbootable. We haven't seen that as much with applications, so we feel a little bit more comfortable doing applications completely automatically. Lastly, once this merge request has been approved, we actually start applying it. So we use Nudge to actually nag employees to update. Nudge being a popular open source tool that delivers pop-ups to employees that remind them of updates and ask them to update. And Jamf will schedule a software update plan for us that implements our chosen deadline. So this is the whole thing again. And we'll just start now with what happens when Apple has released the new macOS version. So the Sofa feed gets updated. If you're not familiar with Sofa, you might be wondering, what is Sofa? Sofa is the simple organized feed for Apple software updates. It is open source, it is written and maintained by the Sofa team, and what it gives you is a very rich JSON feed for update definitions. So it actually contains quite a lot of information, the most important one of which being the actual product version of the macOS update. And it also contains information about the CVEs patched in this release, and whether Apple says they are actively exploited or not. It also has information about the update's compatibility with specific hardware. We don't use this in the nudge auto updater workflow, but if you are new to Sofa and you want to get to use Sofa, this is an important feature to be aware of. I also find this a little bit richer than Apple's GDMF feed, so if you're already using that for some automations, I would urge you to have a look at Sofa because there's probably a little bit more information that you can use in your automations that might be more useful for you. So this data then gets passed on. Nudge Auto Updater gets this data and it uses it to pick an enforcement deadline. So Nudge Auto Updater is open source. It's written by me and my co-author Kai again. And Nudge Auto Updater determines macOS update urgency based on your rules from your policy. And it picks the enforcement deadline. And why did I do this? Why did we make this? So these are the security release notes for macOS 15.3. This is actually not even half of the security release notes for macOS 15.3. There are a lot of fixes in most releases. Each of these paragraphs represents a vulnerability that was patched in 15.3. And I used to read all of these by hand. I used to sort through them, find the severity, go on the MVD website, look up the CVEs, try and assess how critical this update was for my organization. And this is time consuming, and when you're reading white on black text, there can be room for error. You might miss lines, you might miss important phrases and words. And I used to worry about this so much that I used to come on the Mac admin Slack and try and figure out, okay, is anyone else panicking about this, or is everyone feeling very calm about this, and try and kind of validate my own decision. So then Sofa came along, and it put all of this information in the JSON you just saw. And I thought, well, if a computer can read it, then a computer maybe can automate it. So I set out and rewrote Nudge Auto Updater to actually try and automate this task of looking at this data, making the decisions that we were making. And this forced us to formalize our software update policy at Molly. It forced us to think a bit more about, like, okay, what actually hard evidence, what actually do we think is too risky for us to accept, and what actually is a risk we're willing to accept. And we formalized it, and we wrote Nudge Auto Updater, and Nudge Auto Updater now just makes sure that that policy we wrote is consistently applied. So I don't have to read through this anymore and make judgment calls. I just have to review a little summary that looks like this. So this is the output the Nudge Auto Updater will give you when you run it. And it will tell you what it did. It will tell you what rule it met to make its decision. So here in this update, at least one patch CVE was being actively exploited. And this triggered the rule. So Nudge Auto Updater was like, okay, well, this is an urgent update. And it's going to be a 1-week enforcement deadline because that's what you've configured an urgent update to require. And we have this nice summary. So Nudge Auto Updater also uses YAML as a configuration file. I am a fan of YAML to some extent. We can have a little look at how this works. So you can set a default deadline for any update. So if you just have a fallback default deadline, any macOS update needs to be installed within 14 days, you can use this configuration key. This is just for if none of the other rules are met. Then you can additionally set multiple other deadlines that deviate from the default if a specific one is met. So this is my 7-day deadline for if my conditions are met. So in this condition, I have the proportion of CVEs patched in a release that were being actively exploited. And if that proportion is greater than or equal to 50%, that's considered urgent. And then you go to the 7-day deadline, and then it's enforced. Now, what if you are familiar with the Sofa feed, and you have very complex requirements for your software update automation needs? If you have a vulncheck API key, you can plug it into Nudge Order Updater, and you can use there are some other urgency conditions in there that let you drill down into the individual CVE scores, severity scores of CVEs and their components, and you can do like weighted averages, you can do all kinds of fun arithmetic, and you can really do something very flexible with very, very, very granular data. So if the SOFA feed isn't enough, you can do more. It's very powerful. So that's how Nudge Order Updater actually allows us to automatically make these consistent policy-driven decisions. And between the Nudge Order Updater step and the patch actually being deployed, we have the human approval, and then we start pushing the update. Pushing the update is kind of a three-pronged approach for us. We first start with a Slack message that goes out to the company in a public Slack channel. Gives you some links for if you need to know how to install a macOS software update. We do have sometimes employees that have never used the Mac before, so this is very useful for them. Tells you when the deadlines are going to be, what time the deadlines are going to be, and it gives you a summary of what they can expect to see when Nudge starts popping up. So Nudge is Eric Gomez's tool for actually reminding employees of a pending update. And it's an open source tool that pops up, and it does this. And eventually, it stops letting users click it away, and they send tickets like, how can I get rid of this? And for our deployment, we pop it up every noon. So every midday, we actually just do this once a day. We find this to be really the most effective time of day to actually put this notification out there, because a lot of employees are actually just about to step away from their machine for half an hour to have lunch. So as a result of doing this at lunchtime, and we did A/B test this, we typically see about 15 to 20% of our employees up to date after lunch on the first day that we've released the macOS update, which we were pretty happy with. We started using Nudge because it offered more unmissable reminders than our MDM vendor at the time offered. So by implementing Nudge, we also got less updates about help, I'm in a meeting, less tickets rather about help, I'm in a meeting, and my computer is telling me it's going to restart in 15 minutes. We don't get those anymore. People know when there are updates, and they do their updates pretty punctually. We configure Nudge with the JSON file. We don't use configuration profiles to set the deadlines with Nudge. We don't need to worry about AP-NEST delays with this approach. JSON is also a little bit easier to programmatically edit than pulling an MDM profile, editing it, re-uploading it as. And Nudge Order Updater then handles changing the enforcement deadline and the target version in the JSON that Nudge reads. Then lastly, just as a kind of follow-up in case people really, really start to ignore Nudge, we use Jamf's DDM functionality to actually apply a software update plan to machines. So this uses the new declarative management software update feature from macOS 14 to actually force the update on a deadline. This is pretty successful. I'm pretty happy with this feature so far. We sourced the deadline and the target version for this from the Nudge JSON file as well. So we have one place in one GitLab repository that has all of the configuration for this whole workflow. So putting it all together, JSON's kept in GitLab, like I said. We have a merge request workflow, so we've done a little bit of glue code to make Nudge Order Updater suggest merge requests. That isn't a native functionality. We did that in the GitLab pipeline itself. But yeah, it runs every morning. If there are changes that Nudge Order Updater creates, it creates a merge request. And also that markdown report we saw earlier, that text report we saw earlier, becomes the body of the merge request. So you don't even know, you just need to read that. You don't need to read like the pipeline output or anything. It just tells you directly what it did. And once it's been made, then we also test. We test the JSON. This is kind of an artifact of when I used to update the JSON by hand. It just tests whether the macOS version is valid, whether it's actually been released, whether the deadline is valid, and whether the JSON itself is valid. We just want to make sure that we're not sending people macOS versions that don't exist to update to you and stuff like that. Once that's done, it can be approved, and then it goes out. And we have a GitLab runner then that deploys the JSON. So our three-step deployment here is carried out by our GitLab deployment pipeline. And once this happens, the second you click approve, it just goes, does the whole thing. So we deploy the JSON to Google Cloud Storage. So this is where our clients actually get it from. And then we send an API call to Jamf to create our software update plan. So this consists of creating a smart group and applying the plan to it, The smart group is just to make sure that we're only applying the plan to machines that can still receive the update. Even though we don't have any incompatible hardware, it's just a nice fail-safe. And we also want to make sure that we're not applying the plan to machines that have already updated. There's no need. Once both of these steps have actually succeeded and they've happened and we know that they've happened properly, then we send that webhook we saw earlier to Slack, and it's announced to the whole company and they can get started doing their updates. So again, I just wanted to talk a little bit about why we like using this approach. It reduces toil. So these are all of the ones that we've done automatically since we implemented this. We've done basically everything from Sequoia and that last one from macOS Sonoma. We don't need to do manual CVE reviews anymore. We just need to review the report, which is quite nice. We don't need to make any manual gut feeling decisions about deadlines, which is way less stressful. And we don't need to write out any more communication to employees every single release, every 6 weeks. Even with a template, it's a little fiddly, and that's definitely something I should have automated a long time ago. And it follows our rules. Simply put, we have policy, and it's implemented by the code, and it does the same thing every single time. There's no ambiguity about why or when an update is urgent. It's urgent when our rules say it's urgent. And also, we have history for all these changes. We have history of who merged things, who approved things, when they did it. So you can always find out and see, okay, did you make updates to this merge request and then merge it? And if so, why? And it's portable. So we've migrated MDMs twice in the last 3 years. And if we ever did it again, which I'm not planning to, then we can retain this workflow. As long as that MDM has a DDM API for sending DDM software update plans, we can just rework the deployment script a little bit, and we can keep this exact same workflow. So I just want to, that was it. That was the operating system update section. I just want to wrap up. Why should you automate stuff like this? So the most obvious answer is that automations save you time. You can skip the toil and you can get back time for stuff that can't be automated. So you can be like Nakeeb earlier this week and you can actually focus your time on making the user experience better, for example. We've also discussed a little bit app deployment. If I was manually packaging those 132 patch titles, I would be very busy. I am the only CPE at Molly, so I don't think we would get much else done. And also OS updates. Manually assessing and determining those deadlines was costing me, every once in a while, a good couple of hours. And that's a time sink. That's time I could be spending better elsewhere. You can implement your policy as code if you automate as well, which is really nice. If you have existing policy, then you can automate it and you can really stick to it. You can remove that room for error. You can remove that stress of actually having to read through policy every 6 weeks and actually figure out when you're going to apply an update. And for me, that made automating the OS update enforcement deadline pretty valuable, just that I'm not doing gut feelings and I can explain and reason about why exactly we did an update on a specific day. Once you've decided that you want to automate something, how do you pick what to automate? So you should identify repetitive tasks, especially the ones that are not fun. If they're not fun, you definitely should be trying to automate them. Maybe you already have a process whereby you run a bunch of terminal commands one after the other, and that can be a script. That's a form of automation. Maybe there's an API for a SaaS tool you're very frequently clicking around in. That's an automation. You can also look around and see if there are existing open source projects that actually do the thing that you need to automate. If you're new to this and you're thinking, damn, I wish I didn't have to package apps all the time. Well, AutoPackage already exists, and you can already use it. This is a very easy way to get into automating things that doesn't really require you to start writing code first. And if you're comfortable with writing a little bit of code, there might be open source projects that do almost all of your tasks, or they do something very similar to the task that you need to do, and you can adapt them. You can fork them, or maybe you can even make a pull request and you can add features to the one that already exists, contribute. You should think about whether you have existing policy, or policy maybe even that you want to clarify, because sometimes that's the bigger challenge, that could be automated. If you're often fielding questions from colleagues about how or why you do a task at work, this does represent an immediate opportunity to write concrete policy. It helps you understand also how to communicate your work. And it may help you reflect as you're writing about the things that you do on whether there are improvements you can make to the stuff, your existing workflow. I mean, I've been writing this talk since May, and I've already come across half a dozen things that I'm like, oh, why do I do this? And that's for me to try and figure out over the coming weeks. And lastly, if you have a cool internal tool or you have a cool internal workflow that you think other people could use, and if you're writing it at work, your employer allows it, I'd encourage you to open source it. You're probably not the only person looking to solve the problem that you have. There are probably other people who have the same kind of problem, and they're also looking to solve that problem too. And you can help them out. You can open source it. I open sourced Monkey Promoter, and it was, it needed some work when I initially shared it. There were rough edges but people started using it, and they were interested in using it, and they fed back that information to me, and it got better, and it benefited from that feedback. It can be scary to sort of initially put yourself out there and open source something that you've written, but it's worth it in the end. And it doesn't even have to be open source tools. I know that Scott here is also he's written an open source tool he's spoken about this week. But it can also be workflows. James Stewart and Adam Anklewicz also both spoke about AutoPackage this week, about workflows that they do with AutoPackage that they're sharing with everyone. And I think that that's also a form of contribution. Giving that talk, writing that blog post, sharing the work that you're doing, sharing your solution to a problem, that's valuable. I would encourage that. It contributes to the community at large. So before we go to the questions, I just want to give a quick round of thanks. Sam Clark, who I work with, he let me go wild and implement all of this stuff without any question, and then encouraged me to give a talk about it, so big thanks. The authors of all of the open source tooling mentioned in this presentation, so Greg Nagel, the AutoPackage team, all of the contributors to community recipes, the SOFA team, Eric Gomez, and then also lastly Kai for contributing massively to Monkey Promoter and Nudge Auto Updater and helping me sort of write this talk, fine-tune it. I want to thank the organizers of PSU for accepting my talk, giving me my first both MacAdmins opportunity and also speakership opportunity. That was fun. And I want to thank the MacAdmins community at large. Every single person here is contributing to the MacAdmins community in some way. All of this work builds off of the amazing work done by existing community members, even beyond those mentioned above. And I'm very fortunate that I get to build this stuff off of this pre-existing wealth of information that already exists. So thanks for that. And then we have some links. These are in the slides, so I'm just going to skip through these. On the left is a link to the links, and on the right is the feedback link. If you could fill in the feedback, I would really appreciate it. And thank you again for coming to this talk in the last session of PSU. I hope you've had an amazing week. I have had an amazing week as well. And hopefully see you all next year. So are there any questions? Do I have to throw the thing?
Not expecting that. Okay. Is there anything that you don't keep in your Git repository for your Monkey repo?
We don't keep the catalogs because those are built dynamically during the deployment, but we have very recently added the actual installers themselves to the repo. We use GitLFS for that now.
Any issues with that?
We ran into some fun issues because we use Kubernetes runners for our GitLab runners, and we ran into some fun issues where it tried to pull down the whole GitLFS structure, and that works into the runner. We've got disk space for that, but when you start trying to make modifications to it, you run into memory limit errors, and it gets kind of weird. So I wrote a little internal shell script that cherry picks specifically the packages I need to sync and nothing else, so that I reduce that footprint.
Cool.
I was curious if anyone, I'm not sure if you have, we have a smaller team of devs that is moving stuff to Swift.
Mm-hmm.
Have people used Swift with AutoPackage and with Monkey at all?
So to my knowledge, no. But we are looking at this a little bit. So Monkey Promoter is going to stay in Python because Monkey Promoter doesn't rely on Monkey's Python. But we are looking at some stuff with Monkey that will be written in Go, primarily because Monkey Facts are going, we have our Monkey Facts binary is all in Python, and we need to change that out before Monkey 7. So that's going to be Golang, and a couple of other bits and pieces around that will end up being Go. But otherwise, no.
Are you using a Monkey plugin for your cloud storage, or how is that working, like with auto package and with clients connecting?
So auto package just uses auto package commits right to the Monkey repository, and the Monkey repository we use all of our GitLab runners are hosted in GCP. So we use like OIDC authentication to like authenticate with GCP and like do that sync, that rsync up. Clients getting the data out, I wrote like 2 years ago, I wrote a Golang binary that we deploy as a cloud function that clients talk to. That's where that's the Monkey repo URL is that cloud function, and it returns a signed URL when they make an authenticated request. So we just use like Monkey's basic auth configuration, and it basic auths against the service, and then you get a signed URL and it's valid for 15 minutes and the client downloads it. We're looking to move towards MTLS, but that's still yet to happen.
Oh, thanks.
If that's it, I mean, you're free to go to lunch. Thank you very much for coming.